This is College Board SAT practice test number 2, section 4, questions 21 through 38. Number 21, a project manager estimates that a project will take X hours to complete where X is greater than 100. So estimates X hours. The goal is for the estimate to be within 10 hours of the time it'll actually take to complete the project. Cut. Let's first understand the hell they mean by within 10 hours. Let me give you an example. If you and I were to meet at the mall by 7 o'clock and I'm like, yo, I'll be there within 30 minutes. Does that mean I'm gonna be there 30 minutes later than 7 or 30 minutes earlier than 7? It actually means both. If I tell you I'm gonna be there within 30 minutes of 7 o'clock, that could mean I could be there as early as 6:30 or as late as 7:30, meaning I'll be there anywhere in between 6:30 and 7:30. Just like that over here, when they say you want the estimate to be within 10 hours, that estimate better be at most 10 more hours or at least 10 less hours than the actual time it'll take to complete the project. So let's see what that means. If the manager meets the goal and it takes Y hours to complete the project, so that Y hours is the actual. So once again, you want the estimate to be within 10 hours. So you want the X, the estimate, you want the X to be in between, anywhere in between the time it actually took, Y hours minus 10 or Y hours plus 10. Does that make sense? First thing first, if you guys understood what this within 10 hours means, then basically you understood that there should be two different parts to it in terms of inequality. So you gotta have two inequalities, meaning only freaking D makes any sense to begin with. So I would get rid of all these three choices. Number 22. Questions 22 and 23 refer to the following equation. Well, I'm giving this a little equation. What the hell are those variables? R is the distance, and then I is the intensity, and P is the power. Okay, cool. 22. Which of the following expresses blah, blah, blah? I don't want to read it because basically I'm just playing with the equation right here until I leave the R square alone. So first thing, I want to multiply by R square on both sides. So cancel that. So let me continue on here. That'll be R square times I is equal to P over 4 pi. Let's go ahead and multiply both sides by 1 over I. Why would I do that? So that the i's would cancel, and that'll give me R squared is equal to P over 4 pi I, and that's basically B. Number 23. For the same signal emitted by a radio antenna, the observer A measures its intensity to be 16 times the intensity measured by observer B. So cut A versus B. A is 16 times more intensity than B is. Okay. The distance of the observer A from the radio antenna is what fraction of the distance of observer B from the radio antenna? So basically that times 16 on the intensity mainly came from the difference in the distance is what they're saying. So we want to compare that distance. Let's just think of it this way. They are both calculated by using this equation here. So intensity is equal to P over 4 pi R squared. And then also over here, intensity is equal to P over 4 pi R squared. We know that we don't have to worry about this P because they never mention anything about the P. Don't worry about this 4. Don't worry about this pi. It basically was just this R square that caused the A to be times 16. So just think of it this way, that R square caused the times 16. Which means if you think about it, just square root both sides. That means R caused times 4. And basically, I see 4 right here, so I will just go ahead and circle A and move on. Number 24. The equation of a circle in the XY plane is shown above. Okay, so it's a circle equation. What is the radius of the circle? Now, circle equation must look something like this. And this equation, the circle equation, you must memorize this. So where H and K is the center and then R is the radius. Now, does this given equation look like that? Hell no. So our job is to make it look like that. First thing first, let me put the X's and Y's separately together. So like this. So I'm gonna do the X's. X's look like this, and then the Y's look like Y squared minus 2Y. And then we have this -1 on the right side. Now, first thing, I have to make it look like this. And it hell doesn't look like that right now. So I need to complete the square. So if I want to make that something square, it's probably going to be X plus 2. So when you FOIL it out, you get the nice little 4x in the middle right here. Now, if you FOIL this, you will get that plus 4 at the end. So make sure you add that plus 4 and also do it to the right side as well. We cannot just add some shit on the left side and call it a day. We got to do it also on the right side too. And then now let's do the Y's now. So that one, you want to complete the squares, and that will be Y minus 1 squared. So when you FOIL that out, you get that nice little minus 2Y in the middle. Now when you FOIL this, you'll also get plus 1 at the end. So add that on the top and also add it to the other side as well. So your overall equation would look something like this. And the ones cancel, that'll be 4. What do we want? We want the radius. And the right side is the R square. So in this case, R square is equal to 4. Just go ahead and square root both sides. So R is equal to, please don't tell me 2, plus or minus 2. Make a habit of putting that plus or minus so you don't F up on the other questions that actually do require you to put that plus or minus down. So in this case, 2. 25. The graph of a linear function f has intercepts at a0 and 0 being the xy plane. If a plus b is 0, okay, and a is not b, which of the following is true about the slope of the graph of f? This condition right here that we're given, this must be met where a plus b is 0. So let me just say this. Let's just say a is 2. Then now what 2 plus what gives me 0? -2. So just call a 2 and b -2. So 2 and -2. You know what? Let's just do this. 2, 0. That's right there. 0, -2. That's right there. And they want a linear function? Yeah, just draw a line. What do we know about this? Slope, it's positive slope. 26. The complete graph of the function f is shown blah, 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 blah. Which of the following are equal to 1? Remember, it's called f of x. The inside the parentheses is the x value, and f of x is the y value, like they tell you over there. So here we go. Roman number 1, f of -4. Once again, what's 4? X is -4. So this question's asking you, what is the y when x is -4 on the graph? On the graph. So let's go to the graph and go to where x is -4. 1, 2, 3, 4. On the graph, it's right there. What's the y value? It's 1. So, which of the following is equal to 1? Yep, this Roman number 1 works. So it's cool. Let's do another one. F of 3 over 2, 1.5. What's 3 over 2? X is 3 over 2. So let's go. It's right there. And go up to the graph. What's the y value? 1. This also works too. One more. So this works. Now, Roman number 3, f of 3. X is 3. So let's go. 1, 2, 3. On the graph, it's right there. What's the y? It's 1. That still works too. All of them, 1, 2, 3, all work. Number 27. 2 samples of water equal masses. Don't read the first sentence because we see the graph up there. The samples are then left for 70 minutes to cool down and a blah, blah, blah. I see it up there too. So get rid of that too. The graph above shows blah, blah. Don't read this too. Which of the following statements correctly compares the average rates at which the two temperatures of the 2 samples change? So first of all, it's a whole lot of wordings, but let me just take a look at this first. If you guys look at the insulated, let me do the insulated with red and the non-insulated with blue. So if you look at the insulated, if I connect all the dots, it kind of looks something like this, right? Kind of looks something like that. So kind of like linear, but it really isn't a linear, but whatever. And then the non-insulated looks something like this. If I just connect all the dots, it looks something like that. Well, hell yeah, that's definitely freaking exponential. That's not linear. And if you guys notice something, look at the red. It kind of comes down all throughout at about the same rates. It's about the same, right? Look at freaking blue though. That's freaking hell big of a difference. Check this out. If you look at it over here, it decreased so fast. And then if you kind of look at over here, it kind of levels off. And it's very obvious that it decreases super fast and then kind of levels off. Whereas, once again, red is kind of like all throughout the same. Like, it's not exactly the same, but kind of like pretty same compared to blue for sure. So, if you look at choices A and B, look at what they say. In every 10-minute interval, can I conclude anything in every 10-minute interval? Freaking absolutely not. Because if you take a look, the non-insulated, the blue, decreases a lot faster in the beginning. But then later, the red insulated changes more. So, we cannot generalize that whole thing for every freaking 10-minute interval. Get rid of these two. They don't make any sense. So let me read D and see what it says. D. In the intervals 0 to 10 minutes and 10 to 20 minutes, the rates of change of the temperature of the non-insulated, the blue, non-insulated sample are of a greater magnitude. Is that true? Absolutely yes. In the beginning, 0 to 10 and 10 to 20, from 0 to 20 basically, the blue changes faster, not the red. And then after that, red changes faster. So let me just double check that part too. Whereas the intervals from 40 to 50 and 50 to 60, aka later, the rates of change of temperature for the insulated sample are of greater magnitude. Absolutely. D is correct. Number 28, in the XY plane above, ABCD is a square and point E is the center of the square. Okay, I see that all there. I don't really need this. The coordinates are 7, 2, 1, 0 for C and E. So 7, 2, and 1, 0. Okay. Which of the following is an equation of the line that passes through the points B and D? Well, B and D are right here. So I want a linear equation that looks something like this. Well, let's do this. First of all, it's a negative slope. Does that look flat to you or steep to you? The hell looks steep, right? Steep means big slope. Negative, big negative slope. AKA 1/3. That's way too small to be true. Next thing, let's look at the y-intercept. It kind of looks up there around 3-ish. But remember, it's positive y-intercept. Let's see. If you distribute this, that'll be negative 3x plus 3. I like that. A's not it. It's got to be B. Number 29. In the system of equations above, A and B are constants. Cool story, bro. For which of the following values of A and B does the system of equations have exactly 2 real solutions? How do I do this? First thing first, y is 3, so let's just put 3 right here. So I got that. But if you remember the rule, we have 3 missing variables, only 1 equation for it technically. Well, so there's no way I can solve this. What do? Plug in the choices that are in the answer choices and just check whichever one is the answer. So we're gonna start from the bottom, D. So if I were to try choice D and plug all the values into this equation, it's gonna look like this. 3 is equal to A, which is 4, x squared, B, which is 3. So subtract 3 on both sides, and 0 is equal to 4x squared. So divide by 4 on both sides, and that would give me x squared is equal to 0. Square root both sides, x is equal to plus or minus, but it's freaking 0. So it's just 0. Now, is that a real solution? Yeah, because 0 is a real number. But how many is that? That's just only one freaking 0. So there's only one real solution. So out. D doesn't work. Let me try choice C now. So if we were to plug in this choice C into this equation over here, that'll look like 3 is equal to A, which is 2, x squared plus 4, which is B, which is 4. So go ahead and subtract 4 on both sides, and I get negative 1 is equal to 2x squared. Divide by 2 on both sides, and I get x squared is equal to negative 1/2. This is what is not real. That's imaginary number. So C is not real. It's imaginary. Goodbye. Now we'll try choice B and hopefully this works. So if I were to plug that into this equation right here, it's going to look like this. 3 is equal to A, which is -2, x squared plus B, which is 4. So go ahead and same thing, subtract 4 on both sides. And that is -1 is equal to -2x squared. Go ahead and divide by -2 on both sides. Boom, boom. That actually turns into +1/2 is equal to x squared. So square root both sides, and the whole point is it's plus or minus radical 1/2, and that's totally cool. I got +1/2 and I got -1/2. Oh, well, radical 1/2. Whatever that value it is, that's 2 real solutions. Enough is enough. B is good. Move on. Number 30, the figure above shows a regular hexagon with size of length A cut. So there are the A here and a square with side length of A cut. So all A's right here. Okay. If the area of the hexagon is 384 radical 3 square inches cut. So this is 384 radical 3 inches. What is the area in square inches of the square? I'm just gonna assume I'm one of those people who do not know what a hexagon area formula is, and neither is it even in the front of the packet either. Check this out. It does not say figure not drawn to scale, so I can just go ahead and assume what I'm seeing is real. Check this out. That is a square, and imagine if you were to like just superimpose it, so just put it on top of that hexagon. You can almost think of it as just like a paper, and I'm just gonna fold it. And can you see that it's probably gonna be taking up about that much of the space? Can everybody see that? So it's really about that much of a space that it's gonna take up on that hexagon. So first of all, that 384 radical 3, if you guys punch that into your calculator, you get about 665.1075101. I'm just going to call it about 666. Now, because, check this out, that little square region on a whole hexagon, well, it kind of looks like it's definitely less than half of the hexagon. So that square is less than half of the hexagon. But in terms of the hexagon, it looks more than a third. More than a third of the entire hexagon in terms of the area wise. So it should be more than a third of the hexagon. It just kind of looks like it. And can I just believe what I see? Absolutely, because it does not say figure not drawn to scale. So, knowing that hexagon is 666, I can say, well, my square is anywhere in between 333 and 222. And if you look at the answer choices, only A is the answer choice that actually fits in between the two inequalities. And indeed, A is the correct answer. Number 31, a coastal geologist estimates that a certain country's beaches are eroding at a rate of 1.5 feet per year cut. So plus 1.5, plus 1.5, plus 1.5, whatever. According to the geologist estimate, how long will it take in years for the country's beaches to erode by 21 feet? So 1.5 feet per year to get to 21 feet. How many years? It's just proportions. You can just go ahead and set them equal like this, call that x, well that's 1 year, and cross multiply, or you can just 21 divided by 1.5, whatever you want, but just cross multiply. That gives me 1.5x is equal to 21, so just go ahead and divide by 1.5 on both sides, and that's how you get x is equal to 14. Number 32, if h hours and 30 minutes is equal to 450 minutes, what is the value of h? Well, let's see. 450 minutes. Let's try to convert that into hours. How do I do it? Once again, the unit conversion thing. 60 minutes per hour, and I'm putting the minutes on the bottom. The reason for that is when I multiply, the minutes would cancel because I want the hour ultimately. So if you don't want to bother doing this, just do it in your calculator, and when you do this, you get 7.5 hours, which means it is 7 hours and 30 minutes. So h hours 30 minutes, 7 hours 30 minutes. I guess h is 7. Number 33, in the xy plane, the point 3 and 6 lies on the graph of the function this. What is the value of b? First of all, that 3 is the x value, the 6 is the y value. So what do you think I'll do with this? Just freaking plug it into all here. F of x, another word for f of x is just y. So basically 6, the y, is equal to 3 times the 3, which is the x, minus b times 3, which is the x, plus 12. So here we go. Subtract 12 on both sides. Actually, let me work out the right side first. 6 is equal to 27 minus 3b plus 12. So 6 is equal to 39 minus 3b. So go ahead and now subtract 39 on both sides. And boom, we get negative 33 is equal to negative 3b. So go ahead and divide by negative 3 on both sides. And boom, that's how I get b is equal to 11. Number 34. In one semester, Doug and Laura spent a combined 250 hours in the tutoring lab. Cut. So Doug and Laura together is 250. If Doug spent 40 more hours in the lab than Laura did, cut. So if you want to set them equal, who's going to need that buff? The Laura, the small, needs the buff. So you got to put that plus 40 on the small so that small plus something can equal the big. How many hours did Laura spend in the lab? So we're interested in finding the L. Well, first of all, we know D is equal to L plus 40. So just put that right in here. So that's over here into this D. So L plus 40, the Doug, plus L is equal to 250. So that gives me 2L plus 40 is equal to 250. Go ahead and subtract 40 on both sides. And I get 2L is equal to 210. Divide by 2 on both sides. And that is how I get Laura, which is equal to 105. Number 35. Jane made an initial deposit to a savings account. Each week thereafter, she deposited a fixed amount to the account. Let's look at this equation. Well, if you guys understand the linear equation, that 18 is the slope, aka that's the amount this is increasing by, aka that's probably how much she is depositing it in. So deposit each week probably. And then the $15 is probably the initial deposit, because that's the y-intercept, that's the beginning amount. The equation above models blah blah blah. According to the model, how many dollars was Jane's initial deposit? Oh my goodness, I just said initial deposit of that 15 bucks. Answer's 15. Number 36. In the figure above, point O is the center of the circle, and line segments LM and MN are tangent to the circle at points L and N respectively. First of all, when they say a certain line segment is tangent to the circle, that means they make a 90 degrees with that circle at that particular point. So it's 90 degrees over here and over here. And the segments intersect at point M as shown. Okay, if the circumference of the circle is 96, so the length around this whole thing is 96. What is the length of the minor arc LN? Minor arc, so we're talking about just this much. So if I want to figure out how much that blue is, wouldn't it help if I know this angle right here? Can I find it? Absolutely. You're looking at quadrilateral. It's kind of like the square or rectangle. They must add up to 360. What are we looking at? 60 over here, 90 over here, 90 over here. Can I find this? Yeah. Just go ahead and 360 minus all of these guys. That's 180, so 60 together, 240. So that I get 120. So over here is 120 degrees. What do you know about circle? The whole circle is 360 degrees, and we're looking at, out of that, we're looking at 120 degrees worth of it, meaning that's just 1/3. So what do I know about this blue arc? It better be 1/3 of the length of the whole entire circle. Which was what? 96. So what do? Take a third of the entire circle's length, which is 96. And when you guys do that, that's how you get 32 as your answer. Number 37. Questions 37 and 38 refer to the following information. Currently has 3,000. End next year, end this year, next year, whatever. And there's that little equation that looks nasty, but whatever. But let me just go to the question. Number 37. According to the formula, what will be the number of plants? 2 years from now, if k is 4,000. 2 years from now. Keep that in mind. 2 years from now. So here we go. Let's just plug everything we know into this equation. Number next year, number this year. This year I know. That's 3,000. That's this year. This currently has 3,000. So let's go. Let's just plug everything. So n next year, I'll just call it ny, is equal to this year 3,000 plus 0.2 this year 3,000 times 1 minus this year 3,000 over k. Well, they gave it to me 4,000. So 4,000. All right. Let's just do this in my calculator. So 3,000 plus, well, that'll be 600, I think. And then times 1 minus, that would just be 3 over 4. So that'll be 3,000 plus 600 times 1/4. And that'll be 3,000 plus 150. So 3,150. And that's my answer, right? Hells no. No. You got it right. You're on the right track. But that's not my answer because that's the number next year. We just said 2 years from now. So this is after 1 year. This is after 1 year. We gotta do the next year too. So what do? I gotta do another round of this, except now we do the same thing, number next year, but we plug in over here the 3,150 for this year because we're assuming 1 year already has passed. So I'm in the next year already, and then 3,150 is the starting number for the next year. So that's 3,150, and we gotta do this again, round 2. So 0.2 this year 3,150 times 1 minus 3,150 over 4,000. One more round basically. So this is equal to 3,150 plus 0.2 times 3,150, which is 630 times 1 minus, 3,150 over 4,000. Just do that in your calculator. I wouldn't do that in my head. So 1 minus that, I got 0.2125, and multiply that by 360. That's 3,150 plus 133.875, and add that to 3,150, and I got 3,283.875. It says round your answer to the nearest whole number, so that must be 3,284, and that's your answer. Number 38. The botanist would like to increase the number of plants that the environment can support so that the population... Just don't read it. There's no number, nothing. Just ignore it. If the botanist's goal is that the number of plants will increase from 3,000 this year to 3,360 next year, how many plants must the modified environment support? But let's just use this equation one more time. So they told me everything. Next year must be 3,360. This year's 3,000 plus 0.2, which is 3,000 this year, and then times 1 minus this year 3,000 over k. Oh, maybe this question is asking for what the k is. See, I didn't even know what the hell they meant by how many plants. I just plug it in, and I just happen to be missing only the k, so maybe I'm freaking looking for the k value. So let's just solve for the k. Here we go. First thing first, subtract 3,000 on both sides. Boom. And get that out of the way. That's 360 is equal to, multiply that'll be 600 times 1 minus 3,000 over k. Let's divide both sides by 600 to cancel that. So boom, 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 just cancel that. And that'll give you 3/5, and that's equal to 1 minus 3,000 over k. So now go ahead and subtract 1 on both sides, and common denominator, call that 5 over 5. Well, 5 over 5 over here. So that'll beat negative 2 over 5 is equal to negative 3,000 over k. And then just cross multiply. So 3,000 times 5 is equal to 2k. Divide by 2 on both sides. You can just do it all in your calculator. And that's how you get k is equal to 7,500. So that was the end of the College Board SAT practice test number 2, and I will see you guys with the College Board SAT practice number 3 on the next videos.